Hi everyone, this is the second video for predicted questions of paper 4, and these are the topics that we will be discussing. These are the topics of the predicted questions that we will work on now, and you can also find a PDF of these questions in the description. So then let's get started with the first topic that we have. So in this question, this is a question based on percentages, ratios. Then we will discuss about foreign currency and also about exponential decrease related questions. Also, please make sure to watch the prediction video that I made for paper 2 as well as for paper 4, because some important questions are there in both the papers, and especially a compound interest question is there in paper 2. So this is also related to that, but then this is going to be an exponential decrease that we will be discussing. So then let's get started with the first question. So there are certain formulas that we need to know and we need to remember. So I'm just gonna quickly show that to you so that you can go through that first. Here we go. These are the formulas and things that we need to know. So now this part that we have here is about a percentage increase or a decrease question. So there, when the starting amount is given, we first find the multiplier and multiply it with that multiplier to find the final amount. So this multiplier is the percentage that we write as a decimal. And if the final amount is given, and if you are to find the starting amount, in that case, you find the percentage given to you, whether it's a percentage increase or a percentage decrease, you find it, you divide the final amount by that amount, by that decimal answer that we get. So that will give us the starting amount. And then now if we are supposed to find the percentage profit, percentage discount, percentage increase, we can make use of this formula. But if it's percentage profit, it should be profit at the top and always out of the original amount. So in this case, the percentage profit means it's going to be the cost. But if it's a percentage discount, again, it's going to be discount out of the cost times 100. So that is the original amount that should be in the denominator. And when we have currency related questions, it's important that the same currencies are written on the numerators or in the denominators. It should be in the same side. And when it comes to compound interest questions, we always go with this first formula. So in a compound interest question, or if there's an exponential increase like the population growth, in that case, we will have to make use of this formula where you will have an addition in it. The same formula will be used with the subtraction if there is an exponential decrease, like if we are trying to find the half-life of a radioactive substance. So then let's work on questions based on this. And the questions that I have selected are from different past papers. So I have compiled it, and then we are going to work on those questions now. An orchard has 1,250 trees. The trees are in the ratio apple to pear to cherry, 12 to 9 to 5. Calculate the number of apple trees. First, these portions should be added together to calculate the total number of parts, which is I need to add 12, 9, and 4 together. When I add them together, it makes 25, which means out of 25 portions, now we need to see how many are apple. So apple trees are going to be 12 portions. So I can write that as a fraction. So it's going to be 12 out of 25. But we need to find the total number of apple trees out of this 1,250 trees. So I need to times it by the total that is given to us. So 12 over 25 times 1,250 is equal to 600, which means there are 600 trees among these 1,250 trees. Then last year, in the orchard, the mean mass of fruit produced was 64 kilogram per tree. Calculate the total mass of fruit produced last year. Give your answer in tons. Now, 64 kilograms is produced by a single tree. So then the total mass we need to find. And in this case, they haven't mentioned specifically which fruit that is considered. So in this case, it's going to be the total. So that's going to be for 1,250 trees. So 64 per tree. We have 1,250 trees, so we need to times these two together. When we do that, we get 80,000. So this is going to be in kilograms. but we are supposed to write our answer in tons. 1 ton is the same as 1000 kilogram. So that means I need to convert this kilogram into tons. That is converting a smaller unit into a larger unit. When comparing kilograms and tons, kilograms is a smaller unit compared to tons. So to convert the smaller unit into tons, I need to divide it, and I need to divide it by 1000. So when I divide 80,000 kilogram by 1000, it becomes 80. This is the same as 80 tons. In the next part of the question, last year, the mean mass of pears produced was 54 kilogram per tree. This was a decrease of 10% on the mean mass. So then it is a percentage decrease. Is a decrease on the mean mass of pears produced per tree from the year before. Calculate the mean mass produced by each pear tree the year before. Okay, so we need to find the amount of pears produced the year before. So the mean mass of pears produced the year before. Now in this case, we know that there is a decrease of 10%, which means the original is considered as 100. I need to deduct this 10. That is because it's a decrease. If it's an increase, I need to add a 10. So when I deduct it, I get 90%. I first need to write this 90% as a decimal. That is, to convert a percentage into a decimal, I need to divide it by 100. So this becomes 0.90. So this will be that multiplier. Now, in this case, the final mass is known to us, which is 54 kilograms per tree. But we are asked to find what is the mean mass before. That means the starting amount is what I'm supposed to find. In that case, I need to divide this final amount by this multiplier, which is 0.90, which means I'm going to divide this 54 by 0.90. When I divide 54 by 0.90, let's see what we get as the answer. So 54, I'm going to divide it by 0.90. When I do that, I get 60. So this 60 kilograms is the mean mass of pears produced the year before. The next part of the question is where the orchard loses 1/5 of its total number of trees in a storm. Calculate the number of trees that remain. So 1/5 is lost means the remaining amount is going to be 4/5, because out of 5 portions, 1 is gone, which means we have 4 portions left. So we need to find what 4/5 of the remaining number of trees will be. So that's going to be 4/5 times the total number of trees that we had was 1,250. So we need to times this 1,250 with this fraction that we have. This is equal to 1,000, which means 1,000 trees are remaining. The next question is something related to currency. Paulo buys some pears from a market. Pears cost $0.54 each, or 0.51 euros each. Paulo pays in dollars for 12 pears. Calculate the change he receives for $10. Now in this case, to find the change he receives, he pays in dollars. That means each pair is going to be $0.54. We need to check how much that is going to be for 12 pairs. So I need to times this 12 by 0.54. When I do that, I get $6.48. So this is the amount that he has to pay. And we need to check how much change he receives if he pays $10. So to calculate that from 10, I need to deduct this 6.48. So when I do that, I end up getting $3.52. So this is the amount he receives as the change. The second part of the question is the exchange rate is $1. $1 is equal to 0.826 euros. Calculate how much more Paulo pays for each pair. When he pays in euros, give your answer in dollars correct to the nearest cent. So this is for one pair. We need to check the amount. And in this case, the currency exchange is given to us. So that's going to be $1 is equal to 0.826 euros. So I'm going to write it in the form of a fraction. In the other side also, I need to follow that same method, where I need to write the euros at the top, dollars at the top, and the euros at the bottom. And in this case, he pays in euros. He pays in euros means, according to the question, he has to pay 0.51 euro each. That is for one pair. And in the question, it clearly asks us to find for one pair. So in that case, I'm going to put 0.51 here in the bottom because that is the amount in euros. I need to find that in dollars first. Then if I'm to do that, I will label this as X, and I'm going to cross multiply this to solve and find what X is. So when I cross multiply, this 1 gets multiplied by this 0.51. So that's 1 times 0.51. That's the same 0.51. And this 0.826 gets multiplied with this X that we have here. That becomes 0.826X, which means for me to find what X is, I need to divide both the sides by this 0.826 because I need to get rid of this 0.826 that I have here. So when I do that, I get the value of X, but this is going to be in dollars. So then this is going to be 0.51 divided by 0.826. When I do that, I end up getting 0.6174. So this is going to be in dollars. So I'll just write it as 0.617. I'll just write like that for now. And this is going to be in dollars. But then the question is, give your answer in dollars, and we need to see how much more he pays. That is what we are supposed to find. So this same pair in dollars is the same as 0.54. So I need to deduct this 0.54 from this amount to see how much more he is paying for each pair. So in this case, when I deduct 0.54 from this amount, I get the value as 0.077. So this is written, we need to write this correct to the nearest cent. So then it's going to be 0.077. Likewise, it keeps continuing. So to the nearest cent means it's going to be correct to 2 decimal places. So I need to round this 7 up, making it $0.08. So that is going to be the amount he pays more. The next part of the question is something related to exponential decrease. This is something very important. So I have explained already about compound interest in the first video that I made for paper 2, in that there is a good compound interest question there. Now here, this is also something related to compound interest formula, but this is going to be an exponential decrease. Now, in the compound interest formula, we use A is equal to P times 1 minus R over 100 to the power N. This P is the initial amount. This is the final amount. R is the rate. Rate is the amount that you get as a percentage. And N is the period of time. But in this case, now if it's a compound interest, this will be an addition here. Or if it's an exponential growth, if something keeps increasing over a period of time, it will be the same formula we would be using. But this is a decrease because it clearly states that the radioactive substance decays at an exponential rate of 2% per day. The initial mass is 80 grams. So that is the reason why we got to go with this formula. So then we need to find the mass at the end of 5 days. So we are going to do the substitution. The initial mass is 80. So P is the initial mass. So I'm going to substitute 80 there. I need to find the final amount. Then this is equal, this times 1 minus, the rate is also known to us. It's going to be 2% per day over 100, and N is the period of time, that is going to be 5 days in this case. So I'm going to put this in the calculator and see what I get as the final mass. So after 5 days, how much mass I will have. So then I have 80. I need to times it with 1 minus. I'm going to put the fraction here. 2 over 100. Then close the brackets and the power will be equal to a 5. So when I do this, I get 72.31. So correct to 2 decimal places, it's going to be 72.31 grams. This is the amount that is remaining after 5 days. The next part of the question is, find how many more whole days after day 5 it takes for the mass to reduce to less than 67 grams. In this case, what we can do is we need to find what this N is. And we need to see how much more days after this 5 days it will be. So what we could do is, we know that on the 5th day, the amount is going to be 72.31 grams. So I'm going to consider that as the initial amount. So I can put it like this. And then I can say 1 minus 2 over 100 to the power n, and we need to see when it will reach less than 67. We're going to replace several values for n and see what we end up getting. So then I'm going to do 72.31 and the bracket 1 minus, the fraction is going to be 2 over 100. I'm going to close the brackets and I need to substitute different values for n to check what I get. Now, for example, if I put 2 here for n, I get 69.44, which means still we have 69.44 amount of grams left. Still, it did not reduce below 67. So I need to keep changing this value for n that we have here. I'm going to make this a 3. Still, it's not 67. It's not below 67. I'm going to make this into a 4. When I make it into a 4, I get 66.69. This is the moment when it has gone below 67. That means it has to reduce less than, it has to go below 67 grams, which means even if you have 67, you shouldn't be considering it. You should consider any amount that you get below 67. That happens when the value of n is a 4. And the reason why the value of n is replaced with whole numbers is because in the question, it clearly is asking us to write the number of days as a whole number of days. So then in that case, it's going to be 4, which means only when this is equal to 4, so 1 minus 2 over 100 to the power 4, this is when you end up getting 66.69 likewise. So this is when we know that the value of n is equal to 4, which means after 4 days, from this 72.31 grams, it reduces to 66.69 grams. And it clearly states us to calculate after how many more days, after day 5 it will be. So that's going to be 4 days. With that, we will be done with this question related to percentages. Let's move on to the next one that we have. The next question that we have is related to quadratic equations. This is very important, which is something to do with algebra, and this is highly expected. So please make sure you go through this really well. And also the first question that I have picked here is a word problem. So this is how most of the questions are coming up recently. So I sort of feel that you might really get something like this in the form of a word problem, where you will have to create the expression and then try solving it. So that is what we're going to do now. But before that, we will just quickly go through the concept behind this topic. So when it comes to quadratic equations, once when a quadratic equation is formed, we can solve to find the value of the variable in that quadratic equation. So to solve a quadratic equation, we can make use of the factorizing method, the formula method, or the completing the square method. When factorizing or using the formula method, or even by using the completing the square method, if we are to use it, we should always make the equation equal to a 0. Then factorizing means you need to pair it and put it into brackets, and then make it equal to a 0. That way we can find the value of the variable. If we are to use the formula method, you write it in this format, find what a, b, and c is, and substitute it into the formula that is given. And this will be given to you. And the next one is the completing the square method. Here, we need to make sure that this a is a 1. And once when that is a 1, we divide the coefficient of the second term by a 2. And that is the number that goes inside the bracket and combines with the x. And this is written with a square. And then from that, I need to deduct the square of the answer that I have here. And then I need to make sure to add this c here, and I can simplify that way. That is how we complete the square. And the next one is this completing the square is very important as well, because sometimes you will be asked to find the vertex of a quadratic graph. In that case, once when we complete the square, we write the vertex of the turning point of the quadratic graph will be the values of these two together, but the value that is inside the bracket should be with its opposite sign. So if it's a negative value, it will be positive here. And the value that is outside the brackets, it will be the same. So for example, if we have something like x plus 2 with the square and let's say minus 3. In this case, when we write it within the brackets, we will write the same 2 and 3, but the 3 has to be written as a negative 3 because it should be the same thing. And this 2 should not be the same 2, but we need to change the sign and write. So if it's positive, this becomes negative. So this will be the turning point. Then the next set of questions that we will be discussing will be related to solving quadratic equations, then involving algebraic fractions. And when we have fractions involved, if we have just one fraction on either side of an equal sign, we can cross multiply to solve it. If we have two fractions like this with an addition or a subtraction sign, we need to make sure to combine them and make it into one fraction, and then we need to make use of this cross multiplication method to solve it. And always when you have an equation involving fractions, you can get rid of that by cross multiplying. So to do that, make sure we have just one fraction on either side of the equal sign. If it's not like in this case, you need to make them into one fraction on either side, and then you can cross multiply. And the next one is relating the indices. So when it comes to indices, when they have the same basis, if they are being multiplied, we need to make sure to add the indices together. And if they have the same base and if they are being divided, we need to subtract the indices that we have here. And when you have one or two terms within the brackets, and if we have an index like this, it means that this index gets multiplied with all the terms powers that are inside the bracket. So it can be for multiplication, or it may be division as well. And whenever a certain variable's index is equal to a 0, or certain expression's index is equal to a 0, that will always be equal to a 1. And we can also get questions related to indices, but in the form of equations. So when there are questions related to indices in the form of equations, we need to make sure that if the bases are equal, if there is a way for us to prove that the bases are equal, then we can say that the indices will be equal. The same way, if there is a way for us to say that the indices are equal in the equation, then we can say that the bases are equal. So now let's work on the question. So in this question, Darpan runs a distance of 12 kilometers and then cycles a distance of 26 kilometers. His running speed is x kilometers per hour and his cycling speed is 10 kilometers per hour. And the total time taken is given to us as 2 hours and 48 minutes. We need to write an expression for the time in hours. Darpan takes to run is given to us as 12 over x. Write an equation in terms of x for the total time he takes in hours. So here this is something to do with speed. So when it comes to speed, speed is equal to distance over time. So if I need to find what time is, I need to switch the speed and time together. So when I switch them, I get time is equal to distance over speed, which means the distance has to be divided by the speed. So that's how for the first 12 kilometers traveled, the 12 kilometers is divided by, that is the distance divided by the speed, which is this x kilometers. So I need to write a formula for the equation for the total time taken. In that case, for this, with this 12 over x, I should also add the next portion that we have, that is for 26 kilometers traveled at a speed of 10 kilometers per hour. So I need to find the time for that. So again, the distance is divided by the speed. So the distance is 26, and I need to divide it by, here it's not just 10. It states that the cycling speed is 10 times faster than his running speed. That means it's going to be 10 plus x. So I'm going to put this 10 plus x here. This is equal to, in the other side, we have to write the total time taken. So the total time taken should be in hours, because here the speed, distance, time, everything is given to us. Speed is given to us in kilometers per hour, distance in kilometers, and time should be in hours again. So that means this 2 hours and 48 minutes, I'm going to convert it into hours completely. So to convert that into hours, I'm going to times the 2 that I have here with 60. So when I do that, I get 120. With that, I'm going to add the 48 minutes. So that's going to be 168 minutes completely. But I need to convert this into hours. So I need to divide this by 60. So when I divide this by 60, I get 14/5 or equal to 2.8. So I can say that this is equal to 2.8. So then this is how the equation should be. The next one is, show that this equation simplifies to 7x squared minus 25x minus 300 is equal to this 0. So now if I'm to do this part of the question that I have here, I'm gonna first consider the fractions that are given here. I'm gonna write that again. 26/10 plus x, this is equal to this 2.8 that I have here. Or I can even write this 2.8 that I have here in the form of the fraction as well, because 2.8 as a fraction is equal to 14/5 that we got. So I'm going to write it as a fraction because that is much more easier. So 14/5. Now for me to solve this, now I need to make sure to add these two fractions together, because I need to make sure I have just one fraction on either side of the equal sign. Only then I can make use of the cross multiplication to solve this. So I need to first add these two fractions together. So the common denominator for these two fractions will be x times 10 plus x, because I need to multiply this denominator with this denominator that I have, which is 10 plus x, and this denominator with the x that I have in the first fractions denominator. I need to do the same thing to the numerators as well, because if I make a change to the denominator, I need to make the change to its numerator as well. So that becomes 12 times 10 plus x, and in the other side I have plus 26 times x is 26x. This is equal to 14/5. Now I need to get rid of the brackets, so I'm going to expand it. So 12 times 10 is I'm going to write it here, that is 120. 12 times x is 12x, then I have 26x, and then the next one is I have 14/5. I'm gonna write this over 10x plus x squared, because I'm gonna expand this as well. So this is equal to 14/5. Now I'm gonna cross multiply, but before cross multiplying, I'll combine all the like terms. So I have 120 plus, I have 26, and then we have 26 and 12. So 26 and 12 together is equal to 38. So I can write it as 38x. Then that is over this 10x plus x squared. This is equal to 14/5. Now I'm going to cross multiply. So when I cross multiply, I get 5 times 120 plus 38x. This is equal to 14 times 10x plus x squared. I'm going to expand this now. So 5 times 120, I'm going to check what that is. That is going to be equal to 600. 5 times 38. So 5 times 38 is equal to 190x. And then I have 14 times 10x, that's going to be 140x. And then I have 14x squared. I'm going to take all these terms to one side. So that is, I'm going to take this 600 and 190x to the other side. So I have 0 here, and I have 140x plus 14x squared. Then I have minus 190x minus 600. So when I simplify this, I get 114x. I will write the term with the square first. So that's going to be 14x squared. And this 140x and minus 140x, I can simplify together. So when I simplify, I get minus 50x. And then I have minus 600. I'm going to put the 0 equals in the other side as equal to 0. Now I need to make it look like this equation. So in this case, I need to divide all the terms that I have here by a 2. So 14x squared, when I divide by a 2, I get 7x squared. 50 divided by 2 is minus 25x. Then I have minus 300. 0 divided by 2 is the 0. So this is what we are expected to get, and we have shown that. In the next part of the question, use the quadratic formula to solve this equation that is given to us. So that is the equation that we found in the previous step. We need to solve this using the quadratic equation. So for us to use the quadratic equation, the quadratic formula, first we need to identify what a, b, and c is. So in this 7x squared minus 25x minus 300 is equal to this 0. And the quadratic equation is of the form ax squared plus bx plus c is equal to 0, which means the value of a is 7, the value of b is negative 25, and the value of c is negative 300. So I know what a, b, and c is. Now I'm going to substitute it into the quadratic formula, which is x is equal to minus b plus minus the square root b squared minus 4ac over 2a. So I'm going to substitute the values now. So then I have minus the value of b, which is minus 25, plus minus. Then I have the square root. The value of b is minus 25 squared minus 4 times the value of a is equal to a 7. And then I need to times it with the value of c, which is minus 300. This entire thing that I get here should be divided by 2 times the value of a. The value of a that we get is, the a is 7 here. So I'm going to put this in the calculator and see what we end up getting as the value. So then this will give us 2 values for x. So let's see what those 2 values for x are. So then the way how we should find those 2 values for x will be, once we need to put with this plus, and the other time we need to put it with this minus. So I'm going to put the fraction minus 25, close the bracket, plus, then I have the square root, open the bracket, minus 25 square minus 4 times 7 times minus 300. And in the denominator, I have 2 times 7. So when I do that, I get 8.571 as the answer. And the same way, I need to move this, I need to move the cursor and make the plus that I have here before the square root into a minus and see what I get as the answer, because this will give us 2 solutions. So that is minus 5, which means the 2 values that we get are x is equal to 8.571 and the other value that we get for x is minus 5. And this x is equal to 8.7575, I'm going to write it as a fraction as well, because we might need it in the next step. So that is going to be the same as 60 over 7. Now, in the next part of the question, calculate the number of minutes Darpan takes to run the 12 kilometers, which means now we need to calculate the number of minutes taken. So we already know speed is equal to distance over time. We know that the formula is 12 over time. Time is x. This is what we had previously as well. So that means the value of x should be substituted with what we got here. That means I'm going to do 12 divided by this x. I'm going to replace with this 60 over 7. Or I can write this complete decimal answer that we get as well. So it gives us a more accurate answer. So I'm going to put this in the calculator. So I'm going to do 12 divided by 60 over 7. The 60 over 7 is the fraction for this decimal answer that I have here. So then I end up getting 7 over 5. This 7 over 5 is the same as 1.4 hours. But then we are asked to calculate in minutes. So to convert this into minutes, I need to times it by 60. Because in an hour, we have 60 minutes. So when I do that, I get 84. So this is equal to 1.4 hours. To convert it into minutes, I need to times it by 60. This gave us 84 minutes. This is going to be the time taken in minutes for Darpan to run 12 kilometers. Let's move on to the next part of the question. In this question, we are supposed to make M the subject. Now, we can get a question like this. So in this case, we can see that M is in 2 different places. So I need to make sure that I bring it to the same side first. So I'm going to bring this mg to this side, and I'm going to take this minus 2k to the other side. So this becomes mc squared minus mj, which is equal to 2k. Now, for me to find what m is, for me to make m the subject, now I have m's in two different places. I need to make m the subject. So I need to factorize it. So when I factorize it, I can extract the m that I have in these two terms. So this leaves me with c squared minus g. This is equal to 2k. Now, if I'm to find what m is, to make m the subject, I need to take this c squared minus g to the other side. It gets multiplied with this m. So when I take it to the other side, it gets divided, which means this m is equal to 2k over c squared minus 9. So this is how we make m the subject. So there are instances when you can have square roots involved or cube roots involved as well. But keep in mind that if we decide to put the square root for our final answer, so for example, let's say we have m squared is equal to 2k over c. Let's consider it this way. But I need to make m the subject, means in this case, for me to make m the subject, I need to square root this. So only then I can get rid of the square that I have. I need to do the same thing to the other side. If I just leave it like this, if I just say that m is equal to the square root of 2k over c, we will not get the full mark. Because the moment we put the square root for a number, and if it's a positive number, it will always have two solutions. It will have a positive solution as well as a negative solution. So even when making a particular variable the subject, the moment you put the square root, it's important that we put the plus and the minus sign in front. Only then we can get the full marks for this question. This is an example that I considered here. Now let's move on to the next question that we have. In this question, we are supposed to solve this equation that is given to us. So then we have a fraction here. First, I need to get rid of the fraction to solve the equation. Now, in the right side of the equation, I do not have, it's not a fraction, which means the denominator of this will always be a 1. So for any whole number or anything like this where there is no denominator, there is always an invisible 1 there. So it's like we have 13 minus 4x over 3. And this is equal to 6 minus x over 1. So when we have something like this, like I explained previously, we should always make use of cross multiplication to solve this. As long as you have one fraction on either side of the equal sign, we can make use of the cross multiplication to solve it. So 13 minus 4x times 1 is the same 13 minus 4x. This is equal to, using this 3, I need to multiply this 6 and minus 6 minus x. So I need to solve this. So 13 minus 4x is equal to, using this 3, I need to multiply both the terms inside the brackets here. So 3 times 6 is going to be equal to 18. And then I have 3 times minus x, which is equal to minus 3x. So this is what I have. Now what I'm going to do is, I'm going to bring all the like terms to the same side. So I'm going to bring this minus, I have minus 4x here. I'm going to take this, I'm going to take this minus 4x to the other side and bring the 18 to this side. So when I do that, I get 13 minus 18, because the plus 18, when it goes to the other side, it becomes minus 18. I already have minus 3x here. The minus 4x, when I take it to the other side, that becomes plus 4x, which means 13 minus 18 is equal to minus 5. This is the value of minus 3x plus 4x, which is equal to an x. So now I know that the value of x is minus 5. So to solve an equation means to find the value of the variable, and we have figured that out now. Let's move on to the next question that we have. In this question, this is a fractional index question that we have here, but the fractional index that we have here is a negative fractional index. First, I need to make it positive. To make it positive, to make the fractional index positive, what I got to do is, I'm going to flip this fraction that I have, which means when I flip the fraction that I have here, this becomes x to the power 16, y to the power 8 goes to the numerator. I have 16 in the denominator, and then the fractional index that I have here becomes a positive. So this is how it will be. Now, what happens is, this fractional index belongs to all these terms. That means it multiplies with all the powers of the terms that we have inside the brackets, whether it's in the numerator or in the denominator, which means I already have x to the power 16. this gets multiplied with this power 3 over 2. Then I have y to the power 8. This gets multiplied with this 3 over 2. And then over, I have 16 to the power 3 over 2. But what I'm going to do is, this 16 that I have here, I'm going to write it so that it has a power of 2, because it only then I can get rid of this, I can cancel it with the denominator of this fractional index, which means I can write this 16 as 4 to the power 2, because 4 squared is equal to a 16. This 4 to the power 2 gets multiplied with this fractional index as well, which is 3 over 2. Now we can clearly see this 2 and this 2 can get cancelled out, because it's like fractions where one is in the numerator and the other one is in the denominator. I can cross that out. This 16 and 2 can be simplified as well by dividing both by a 2. So this becomes a 1 and this becomes an 8. This becomes a 1 and this becomes a 4. Now I can write this as x to the power 8 times 3 is equal to 24. Then I have y to the power 4 times 3 is 12 over 4 to the power 3. But this 4 to the power 3's value should be calculated. That is the same as 4 times 4 times 4. So when we find the value of 4 to the power 3, that is equal to 64, which means we get x to the power 24, y to the power 12 over 64. This is going to be our answer. Let's move on to the next part of the question. Here we are supposed to factorize. This is actually a very good question that we have here. So now in this case, when we have 4 terms, we should always pair and factorize it, and we will end up getting 2 brackets. Now when we consider this 4x squared minus y squared, they are all square terms and they have square terms. So which means square numbers and variables with squares, and we have a minus as well. So we call this as the difference of squares. If we have the difference of squares like this, it means that we can factorize it by imagining it as if we are square rooting it. So when we square root a squared and b squared, we get a and b. So we put that a and b within 2 brackets, one with a minus, the other one with a plus. We got to do the same thing here as well. We need to do it as if we are square rooting all the terms here. Square root of 4 is 2, square root of x squared is x, square root of y squared is y. So I need to write this in 2 brackets, but one with a minus and the other one with a plus. So it's going to be like this. Or I can put plus first and then minus next. Now I'm going to factorize this portion that we have here. So that is 8x plus 4y. So in this case, 8x plus 4y, they both belong to 8 and the 4 belongs to the 4 times table. So I can take the 4 out and put the rest, which is this 2x and y, inside the next bracket, inside the bracket. That is how we factorize these 2 terms. Now, this is the answer that I get for this one. So in this case, now I need to solve this further. In this case, what we got to do is now, this is like, now if we have an x here, so for example, if this was an x like this, in that case, we would write the terms within the brackets once, and the terms that are left outside the brackets will be combined together and written in the next bracket. But in this case, this x that we have here is given in the form of a bracket, in the form of an expression, that is 2x minus y. Which means again, this 2x plus y, they are common to both the terms. So I need to write that 2x plus y here. And this 2x minus y is like that x that I mentioned. And we have this 4 here. We need to combine these 2 together and write it in the next bracket. So this is what I get. We do not have any like terms here, so I cannot simplify this further. This is our simplest form. This is the answer in our simplest form. Let's move on to the next one that we have. In this question, we need to find the value of x. We have 3 to the power minus 2 times 3 to the power x. So when indices with the same bases are multiplied together, we need to add the indices, which means when they have the same bases, if they are multiplied together, we need to add the indices like I mentioned. So that becomes 3 to the power negative 2 plus x here. This is equal to this 81. I can write this 81 so that it also has a base of 3, just like I have a base here. base of 3 here. So I can write it as, in this side I have minus 2 plus x, and this 81 I can write it as 3 to the power 4. Now I know that they have the same bases. The bases are equal, which means I can equate the indices. So in this case, I have minus 2 plus x is equal to a 4, which means I need to find this x, I need to bring the minus 2 to the other side. It gets added with the 4. So 4 plus 2 becomes a 6, which means the value of x is equal to a 6. So that is what we are supposed to find here. The next question is actually a very challenging one here. So let's see how we can do this. So similar to this only, we got to do this question as well. So we have an equation involving indices. So we need to try making the indices the same. So in this case, I have x to the power minus 1/3, which is equal to 32 times x to the power minus 2. I'm going to bring this x to the power minus 2 to the other side. So it gets divided because it was multiplying with the 32. So when I take it to the other side, it gets divided. This is equal to 32, which means now this negative 1/3 is being, now they have the same basis, which is x, and it's being divided. So I need to make sure to subtract the indices. So they will have the same base again. I need to now do what negative 1/3 times negative 1/3 minus this minus 2 is minus 1/3, and I got to subtract a negative 2. When I do that, I get 5/3. So here we are subtracting the indices, so I get 5/3. This is equal to this 32 that we have here. Then I'm going to put the 32 like this. Now, I'm going to make this simpler for now, just by giving an example. Now, let's say we have something like x squared is equal to, let's say, a 9. Then for me to get rid of this square here, I need to square root it because I need to do the opposite of that. That is how I can find. I need to do the same thing to the other side. That way I can find the answer for x. I need to do the same thing here, but then in this case, the index that I have here is a fractional index. So I need to do the square root of that fractional index. I need to do the same thing to this side as well. I need to do the square root. I need to put the root of that fractional index. So when I do that, this fractional index and this root will get cancelled out, leaving us with this root of 32. So I need to find the root for this 32. So when I do this, let's see what we get. So I'm going to put the fractional index first. So the fraction is 5/3. That index is written here. And then inside the bracket, inside the square root, I have 32. So this is no longer a square root. We call it as a root here. So it's going to be 5/3 root. So when we do that, we end up getting 8, which means when the value of x here is equal to an 8. With that, we will be done with this question that we have here. Let's move on to the next one. So this question is related to polygons. So we need to calculate the number of sides this polygon has, which has an interior angle of 156 degrees. And this is a regular polygon like it's mentioned in the question. So for us to work this one out, first we will go through the formulas related to this topic that we have. So we have about 5 formulas when it comes to polygons. So if we are trying to calculate the interior angle sum of a polygon, then we need to times the number of sides minus 2 with this 180 degrees. Then that will give us the value of the interior angle sum. And the next one is the exterior angle sum of any polygon will always be equal to 360 degrees. So no matter how many sides that polygon has, it will always be 360 degrees. And when it comes to a regular polygon is a polygon that has equal, that has the side lengths are equal in length. The sides are equal in length. and then the angles are going to be equal as well. Now, to calculate the value of one interior angle, first we need to find the angle sum of that polygon, and we need to divide it by the number of sides. So each of those angles will be equal. So then when we divide it by the number of sides that polygon has, then we can find the value of one interior angle. The same way, if we are to calculate the value of one exterior angle, we know that the angle sum for exterior angles is 360. We need to divide that by the number of sides it has. So we need to divide it by n. Now, here I've written an interior angle plus an exterior angle is equal to 180 degrees. This happens when we have a polygon, and let's say that I'm going to consider a triangle. So when I extend any one of the side of the triangle, this interior angle and this exterior angle, they are on a line, as you can see here. So these two together, as they are on a line, they will make a sum of 180 degrees. Now let's move on to the question. So to calculate the value of one interior angle, we will use the angle sum of an angle sum of a polygon. So that is this formula should be divided by the number of sides. This will give us the value of one interior angle in a regular polygon. Now we know the value of one interior angle in a regular polygon, which is 156. We need to solve this and find what n is. So first I'm gonna expand this. So I'm gonna multiply the n and this minus 2 with the 180 that I have here. That becomes 180n, and then minus 360 over this n is equal to 156. I'm going to bring the n to the other side, that is in the denominator. So it gets multiplied with this 156. This becomes 156n. This is equal to 180n minus 360. I'm going to bring this 180 to the other side. So 156n, this 180n becomes minus 180n. This is equal to minus 360. So now from 156, I need to deduct 180. So when I do the subtraction there, I end up getting minus 24. So this is minus 24 is equal to minus 360. Then to find what n is, I need to divide both the sides by minus 24, because only then I can get rid of the minus 24 that I have here. So this gives us the value of n. So when I divide 360 by 24, I get n as 5, which means this regular polygon, which has an interior angle of 156 degrees, has 15 sides. Let's move on to the next one that we have. This is very, very important. So this is something to do with circle theorems. So, and also it's very important that we know the geometrical reason as to why a particular angle is equal to a particular value. So now, before we do this, we will first go through the circle theorems that we need to know. So in circle theorems, we need to know these circle theorems. So the first 6 are very important. So then when you consider these 6 theorems that are given here, the first one is the angle that is formed in the center by an arc is double the size of the angle that is formed in the circumference. So you can see that this angle is x, so the angle at the center will be double that size. Now, this same theorem is applied here as well, but the angle that I have considered is the reflex angle. So when I consider this angle for this angle that I have here, the angle formed on the circumference will be here. So as you can see here, both the angles that we have here should be facing the same direction, and here both the angles will be facing the same direction as well. So then, now here, the actual theorem that we have is angle subtended in the center is twice the angle subtended at the circumference by the same arc, but we can just write it this way. This is more than enough. And it's very important that we know what this geometrical reason is, because you will be expected to write the geometrical reason. The next one is the radius and the tangent. They are perpendicular when they meet at this point of contact. So that is when the radius and the tangent meet at a particular point here, they will be perpendicular. That means they will have a 90-degree angle in between. The next one is the angles that are formed in the same segment are equal. Now here I have drawn a line here. This is the chord that is given. So from the corners of the chord, we have the angles and they will be equal to each other as long as they are in the same side or the same segment. And sometimes or mostly what happens is this line, the chord, will not be given to us. Even if the code is not given to us, even if this code is not given here, we can still make sure to use the same theorem that we have. The next one is, when we have the diameter, we split the circle into two semicircles. So in any semicircle, when an angle is formed on the circumference, it will always be 90 degrees. The angle will always be a right angle. So whether it's the segment in this side or the segment that we have in this side. And then the next one is about cyclic quadrilaterals. So when it comes to cyclic quadrilaterals, we know that all four vertices of the quadrilateral should touch the circle. And in a cyclic quadrilateral, the opposite angles should always make a sum of 180 degrees. And the next one is the alternate segment theorem. When it comes to the alternate segment theorem, that is the angle that is formed in between a chord and a tangent. So that is relating these two. So this is the tangent that we have here. This is the chord. This is the angle that is formed in between the chord and the tangent. So for this angle will be equal to the angle that is formed by the same chord in this segment. We call that as the alternate segment, which means this angle and this angle will be equal. If I consider this as the angle that is formed between the chord and the tangent, then for this, the alternate segment will be this segment. So in this segment, the angle has to be formed using the corners of the chord here. So that way, these two angles will be equal to each other. And this one is another one that we have here. So here, from an external point to a circle, if we draw the tangents will be equal in length as long as they are from the same external point and they meet the same circle. They will be equal in length. Then we will have to have an idea about isosceles angles, isosceles triangles, and how in an isosceles triangle, the opposite angles will be equal. So opposite angles in the sense, it's the angles opposite to the equal sides. We call those as the base angles. So they will be equal to each other. And when it comes to another triangle, now if I extend this side here, this is going to be the exterior angle for the triangle. This exterior angle will be equal to the sum of these two interior opposite angles. So that is another theorem that we can keep in mind when we work out this topic. So then let's move on to the question that we have. P, Q, R, and S lie on a circle. MPN, that is this line, is a tangent to the circle at P. The angle MPS is 58, PSR is 74, QPN is 27. We need to find angle PRS. PRS is this angle. We need to find how much this angle is. Now to calculate the value of this angle, I'm going to consider this chord and this tangent that we have here. This is the angle that is formed in between the chord and the tangent. So this is the starting and the ending point of the chord, or I can consider this as the starting and the ending point of the chord. Using the two corners of the chord, I'm gonna form this angle that we have here is formed on the circumference, which means for this angle, this section is the alternate segment. Therefore, this angle will also be the same size, which will be 58 degrees. So here we are just asked to write the value of the angle, that is 58. And if we are asked to write the geometrical reason, we will write it as alternate segment theorem. That will be enough. I'll write it here. Then the next one is to calculate angle PQR. So PQR is going to be this angle. Now I need to calculate how much this angle PQR is. Now, first what I'm going to do is, I'm going to find how much this angle is. First, I'm going to find how much this angle is. Then I can make use of the alternate segment theorem again to find the value of this angle. So this is a triangle that we have here. In this triangle, these two angles are known, which means for me to find the value of this angle here from 180 degrees, I can deduct the sum of these two angles, which is 74 and 58. So when I add 74 and 58 together, I end up getting 132. And from 180, I can deduct 132. That gives us 48 degrees. That means this angle that I have here is 48 degrees. But using this angle, this is not equal to this angle here. But we need to use this angle to find what this one is. That's because now this PR that we have here is a chord. Again, this MPN is the tangent. This is the angle that is formed between the chord and the tangent. Using this chord in this segment, this is the alternate segment that we have here. In this alternate segment, the angle is formed on the circumference like this, which means this angle that I have here is the same as this angle that I have, which means this angle PQR is equal to the addition of 58 and 48 degrees. So 58 and 48 degrees together is equal to PQR. So when I add these two values together, I get 106. So this 106 degrees is the value of this angle PQR. The next one is to calculate the value of the angle RPQ. RPQ is going to be this angle. So now we need to calculate how much this angle is. Now to calculate what this RPQ is, now I'm going to consider the angles that are on this line here. This complete angle that we have here, there are angles on a straight line, will make a sum of 180 degrees, which means when I add this 58 and this angle 48, this angle that I have marked in purple that we are supposed to find, and this angle which is 27, when I add them all up, it will be equal to 180 degrees because they are angles on a straight line, which means from RPQ, to find RPQ, from 180, I need to deduct 58, 48, and then 27. So that way I can find what RPQ is. So then let's put this in the calculator and see what we get. 180 minus 58, 48, and 27. So when we do that, we end up getting 47, which means the value of this angle RPQ is 47 degrees. So here I made use of angles on a straight line. Angles on a straight line. Straight line is equal to add up to 180 degrees. So add up to 180 degrees. So this is a geometrical reason you would write if we are asked to write it. And here for this one, we can write the same alternate segment theorem. Also, now when calculating this angle PQR, we could have also done it this way. This angle, which is 74, I can find this angle by deducting this 74 from 180 degrees as well, because these two are angles opposite angles in a cyclic quadrilateral, and in a cyclic quadrilateral, the opposite angles make a sum of 180 degrees. So using that, I can find this one as well. Now, this doesn't mean that now in this case, what happens is we don't have to, there is no set of order as to which angle should be calculated first or which theorem should be used. As long as we know the circle theorems, we can apply whatever that is possible to get to the angle. And in the end, we need to know which theorem we made use of, because if we are asked to write the geometrical reason, we should be able to write that. Let's see what we have next. Question C. This is a question that is relating congruence. So first we will quickly go through the congruence criteria that we have. When it comes to congruence criteria, we have 4 criteria. That is, when all 3 sides of a triangle is equal to all 3 sides of another triangle, we can say that the 2 triangles are congruent. When 2 sides, and this A is actually the included angle. So that is the angle in between the 2 sides considered. If it matches with 2 sides and the included angle of another triangle, the 2 triangles are considered to be congruent. And the third criterion is where when 2 angles and the included side is equal to 2 angles and the included side of another triangle, they will be congruent. And finally, this is applied to right-angled triangles, which is RHS. So they both should be right angles, which means they will have a right angle in it. And the hypotenuse should be equal. And then we have the side. So this doesn't mean that every right-angled triangle will always obey RHS criteria. That's not the case. So even though it can be a right-angled triangle, but there will be instances when we will have to apply the other criteria to prove that they are congruent. If we can prove that 2 triangles are congruent, it means that all the angles will be equal and all the sides, that is the matching sides, or we call it as the corresponding sides, they will be equal as well. In this question, A, B, and C lie on a circle, center O with diameter AC. So this AC is the diameter. TAM and TBN are tangents to the circle, and the angle ATO is equal to 34 degrees. That's already marked in the diagram. Using values and geometrical reasons, complete the statements to show that CB is parallel to OT. So CB is this line is parallel to OT. We need to prove that they are parallel. Those 2 lines are parallel. In triangle AOT, so that is this triangle AOT, this is the triangle that they're referring to, and the triangle BOT, so this is the other triangle. OT is common. OT is common because both the triangles are sharing that side. Angle OAT, that is this angle, and this angle OBT, they are equal to 90 degrees. The reason is because this OA is the radius and this TM is the tangent. So whenever the radius and the tangent intersect, they meet at 90 degrees. So I can write the reason as radius is perpendicular to the tangent. To the tangent at the point of contact, or I can just write it this way. The next one is AT, that is this side, is equal to BT. Now we need to write the reason for this. So this will be tangents from the same external point, are equal in length. So tangents from the same external point that are drawn to a circle, to the same circle, are equal in length, or we can just write it this way. Then due to these reasons, now we have 3 reasons. One is OT is common. There is a 90-degree angle. The other one is there is another side that is equal. And now due to these 3 reasons, we can say that the 2 triangles, which is AOT and BOT, are congruent. And then the criteria is what we are supposed to mention. In this case, it will be RHS because we have right angles. Hypotenuse is also common. And the other side that is matching is one of the shorter legs. So definitely it's going to be RHS. Angle AOT is equal to BOT, that is equal to 56. AOT, that is this angle, is 56 degrees. And this angle BOT, this angle is also 56 degrees. Because 56 degrees, because angles in a triangle add up to 180 degrees. So here the reason why this is 56 is because to find this angle from 180, we can deduct this 90 and 34, which gives us 56. But that is already calculated here, already given here. In the next part, it states that angle BOC is equal to which angle? Angle BOC, that is going to be this angle. We need to say to which angle that is, how much that is equal to. So we can find the value of this angle here. That's because, as we can see here, this is a straight line. So these three angles that we have on the straight line will make a sum of 180 degrees. Which means for me to find this angle here, which is BOC, for me to find BOC, from 180, I can deduct both the 56 degrees that I have here. So that will be equal to, from 180 when I deduct it, that will be equal to 68 degrees. Which means the value of this angle BOC is equal to 68 degrees. And we need to write the reason here. The reason is that there are angles on a straight line, will be more than enough, or if we want, we can write it as angles on a straight line make a sum of 180 degrees. The next one is angle OBC. So that is OBC, that is this angle, is equal to how much? We need to find the value of that angle there. To calculate the value of this angle that we have here, I'm going to draw this triangle separately. So then this triangle is going to be like this. So in this triangle, O to C and O to B, they both are radius of this circle. So those radii will be equal in length. Due to this reason, it makes this triangle OBC into an isosceles triangle. In an isosceles triangle, like I mentioned previously, the sides, the angles opposite to these equal sides will be equal. We call them as the base angles. They will be equal, which means this angle and this angle will be equal to each other. Now, this angle that we have here is equal to 68, which means for me to find these two angles, or for me to find one of this angle, first from 180, I need to deduct 68 degrees, and the answer that I get has to be split into two. So from 180, when I deduct 68, I end up getting 112, and I'm going to divide this by a 2. So when I divide this by a 2, I get 56 degrees, which means this angle is 56 degrees as well as this angle is also 56. So now I know that this angle is 56. So I can write this as 56 degrees. And I need to write the reason as to why that is 56 degrees. So I can write it as angles in an isosceles triangle. So we can write it this way. Then the next statement that we have is CB is parallel to OT because now CB is this line, and why is it parallel to OT? That's what they are asking for. So in this question, now we know that this angle is equal to this angle. So we can form this Z shape, which means in parallel lines, alternate angles will be equal. Here, the alternate angles are equal, therefore the lines has to be parallel. It's the opposite of that. So that is, the angles are equal, which are alternate angles, because alternate angles are in the shape of letter Z. So I can say that CB is parallel to OT because alternate angles are equal. This is the reason. With that, we will be done with this question.